Okay, sorry, I was trying to rush and that video cut off. So I can only record 10 minutes at a time. So this is my step 5, which is interpret, right? Or summarize, as the book says. So there's enough evidence to support the claim that the average age of the doctors in the system is greater than the national average of 46. Okay. Okay. So I told you guys that when you watch this video, there's going to be something for you to do. So what I want you to do is do this problem. Okay. This is also in your book. It's example 8-5. So if you needed some help, you can do it from there. But I want you to read this example and I want you to carry it out. And I want you to turn that into me on Monday. Okay, so that's Monday, November 5th. I expect you to come to class with this example on a piece of paper, worked out following the steps that we just did. I want to point out a couple of things to you. This example is going to be a two-tailed test. Okay, it's because it's differently worded. All right, it just says that we're trying to, so let's read the problem. Okay, so the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $26,343. The standard deviation of the population is 3,251. At alpha equals 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from 24,672? So I'm going to help you with step 1. Okay. So again, I always write the things that I know. So the mu is 24,672, right? Standard deviation is 3,251. X bar is 26,343. And our N is 35. And our alpha is 0.01. Okay. So with step 1, we're trying to find our hypotheses, right? So our null hypothesis is always going to be mu equals whatever value they give you for the population, right? Our null hypothesis here, since it just says we're testing if it's different. So it doesn't matter if it's greater than or less than, it's just mu is not equal. So you have to be careful here when you're finding your Z critical values because you have to split your alpha into 2, like we discussed in 8.1. Okay. Again, go see the book if you're really struggling with this. It's on page 422 and 423. But I really want you to try this on your own first. Okay. There is another method that we can use. It's called a p-value method. All right. And it is very similar. The only difference is when you find, so let's talk about what the difference is so that you know for your homework. All right. So p-value method, you find your test statistic and then find the p-value associated with it. So if we go back to our original example, here is my z-score, right? So back to example 8-3. Our z test was equal to 3.39. right? So all you do in this case is you go look up this value on your Z table and see what the p-value is. So find associated p-value, right? And if the p-value is less than alpha, you reject H naught, okay? So the two things I want you to do this example 8-5 using either method. You can use the critical value, the critical region method that we talked about, or you can use the p-value method. And then the second thing I want you to do is do this finishing out the p-value method, right? So I want you to put on your piece of paper this example worked out, whichever way you want to work it out. And I want you to go back to the example I already worked and use the p-value method. All right, so you should have 2 problems to turn into me on Monday. And have a happy Halloween.